Hi, Michelle Glass here. Welcome to our second episode of Chapter 27, Lecture 27. Previously, we were looking at fluid balance, and this video is all about sodium balance. The key thing that we should be picking up on is that in order to regulate our sodium levels, we see that fluid levels are going to play a role, and vice versa. So they're kind of intertwined. Now, remember, because we have a sodium-potassium exchange pump constantly pumping sodium into the extracellular fluid, our ECF has our highest concentration of sodium. And so it's pretty common to have problems with your sodium balance because it's all located there in the extracellular fluid. So that means it's not as regulated by the cell. Now, in every case that we talk about balance, that means that the amount of gain should equal the amount that's lost. In the case of sodium, of course, we're primarily making gains through our diet, and then losses are happening at the urinary system. Now, the key thing is we're not looking at the total amount of sodium, but rather the concentration of sodium. What we're really regulating is the osmolarity of our body fluids, of those fluid compartments. And remember, we're focusing primarily on regulating the ECF fluid compartment because the cytosol is regulated by the cell. If you take in a lot of sodium from your diet, that sodium is going to move into your bloodstream and into your extracellular fluids. And one of the first responses to deal with that would be for fluid to shift from the ICF into the ECF, which is helping to dilute that. You also might begin to feel thirsty if you're eating that salty snack without a drink. And by taking in extra fluid, then you have more water to help dilute all of that salt that you've just absorbed. Changes in the extracellular fluid osmolarity is detected by the hypothalamus. And we're going to see the release of antidiuretic hormone as a result of a high sodium concentration. So if you are eating a salty meal or like a whole big bowl of popcorn, then you're increasing your sodium concentration. This is going to trigger the release of the antidiuretic hormone, which will trigger facultative water reabsorption at the DCT and the collecting duct, which is going to ultimately help to dilute that sodium, so it's maintaining the balance. If your sodium level or concentration is low, then you want to get rid of extra body fluids in order to concentrate the sodium. So with a low sodium concentration, you're going to decrease your amount of ADH being produced, stop facultative water reabsorption, and concentrate that sodium instead. Now, those little changes that we're talking about, that's just like based on your diet, what food you've eaten and what you've drank. Large changes that occur in the extracellular fluid can equal big changes in blood volume and blood pressure. And so then, of course, we need an even bigger response. We already know that when your blood pressure is high, you get the release of the natriuretic peptide, which is here abbreviated as ANP and BNP. A for atrial natriuretic peptide, and B for B-type natriuretic peptide. And we also already know if your blood pressure is low, then you're going to initiate the RAS, renin, angiotensin, aldosterone system, as well as the release of ADH. So we actually don't have to talk about those mechanisms, but we can do it anyway. Okay. So here is our first specific term, which was actually introduced in the previous video. Hyponatremia is talking about low sodium levels. So natremia is referring to the name for sodium that's giving it its chemical symbol of Na. So when you have a low sodium concentration, we basically are going to remove water in order to concentrate that sodium. And so we can do this with the release of the natriuretic peptide. So let's go through this. So if you have a high extracellular fluid, a high blood volume, high blood pressure, so you have lots of fluid, then that means that your sodium concentration level is too low, is too dilute. So this is going to go together hand in hand. So if you have a high blood pressure, high blood volume, you're going to signal the atrial stretch receptors. The heart releases ANP and BNP. This is going to increase your sodium and water secretion. So you're going to be getting rid of water and sodium at the DCT and the collecting duct. You're going to decrease your thirst, and you're decreasing the ADH, aldosterone, epinephrine, norepinephrine, as well as dilating your vessels. All of this is going to help bring your blood volume and blood pressure back into normal. And also, because you've removed the extra water, your sodium is going to be concentrated, and your body volumes for both fluid and sodium, your osmolarity, will return to normal. In the opposite case, you have high sodium concentration levels. We call this hypernatremia. So in this case, we need to add water in order to dilute out that sodium. And this then means we're going to see hypernatremia when we have concentrated our sodium. So you might also see this when you have a low extracellular fluid, low blood volume, low blood pressure. You're going to see that the kidney will release angiotensin 1, renin. The kidney will release renin, which is going to activate angiotensin 1, which is converted with the help of angiotensin converting enzyme into angiotensin 2. Angiotensin 2 is going to release aldosterone, which is going to turn on the sodium-potassium exchange pump at the DCT and the collecting duct. This is highlighted because, pay attention, if you have aldosterone being released, this is assisting with sodium regulation, but this is also causing potassium secretion. And so it can alter your potassium levels. You also see angiotensin 2 triggering the release of the antidiuretic hormone. So we get facultative water reabsorption at the nephron, and you're going to increase your thirst. In addition to this, you're going to see the sympathetic activation. So epinephrine and norepinephrine are going to be released, increasing your cardiac output and peripheral vasoconstriction. So with all of these things together, you're increasing your blood volume and your blood pressure, which also means that you're diluting your sodium levels and you're returning all of those things back to normal. So the takeaway here is that your sodium level has a direct influence on your blood pressure and your blood volume. And the mechanisms to correct your sodium level will have a direct effect on the blood volume and the blood pressure, because you're not really regulating sodium levels by changing sodium so much as you are changing your body fluids. And that's it for now.